July 14, 1944. 6:47 a.m. Normandy, France. The barrel explodes, not the shell, not the ammunition rack. The barrel itself, 56 calibers of precision-machined Krupp steel. The finest gun barrel ever fitted to a tank, detonates from the inside out in a fraction of a millisecond. The breech ring shreds. Metal fragments the size of fists travel at rifle velocity inside a space no larger than a garden shed. The gunner dies before his body understands what is happening. The loader beside him takes a fragment through the throat. The commander sealed above in his cupola survives only because the blast vents forward rather than upward. He will spend the rest of his life unable to explain what he witnessed. The Tiger I tank, the most feared armored vehicle in the world, has just been destroyed by its own gun. And somewhere in occupied Belgium, in a vehicle workshop that smells of axle grease and fear, a man nobody has ever heard of is doing exactly what he was told to do. He is swapping one small metal plug for another. The whole operation takes less than 4 seconds. He does it again, and again, and again. His name is not recorded in any file that has been declassified. He was by occupation a mechanic, by nationality Belgian, by circumstance one of the most quietly lethal saboteurs of the entire Second World War. The device he is inserting into German ordnance supply creates a length of hardened steel wire, no thicker than a knitting needle, no longer than your hand will go on to destroy, between 40 and 80 Tiger and Panther tanks across 2 theaters of war. It will kill crews that had survived Leningrad. It will eliminate gunners who had fought from Tunisia to Normandy without a scratch. And it will cost per unit approximately the price of a cup of tea. This is not the story of a secret weapon. This is not the story of a brilliant general, or a famous codebreaker, or a daring commando raid. This is the story of how the most sophisticated killing machine of the Second World War was brought down by a piece of wire a stolen 4 seconds and an idea so simple it was almost rejected before it was ever tested. Almost. To understand why the British barrel obstruction program was necessary, you need to understand exactly how badly the Allies were losing the armor war in 1942 and 1943. Not losing tactically. Losing catastrophically. When the Tiger I first appeared on the Eastern Front near Leningrad in September 1942, Soviet anti-tank crews reported something that their training had not prepared them for. They were firing at targets they could not kill. Standard 45mm anti-tank rounds were bouncing off frontal armor at ranges where they should have penetrated. 76mm gun crews were reporting the same thing. The Tiger's 100mm frontal plate, combined with its sloped geometry, was defeating weapons that had been adequate against every previous German tank. The gun was worse. The KWK-36, the 88mm weapon fitted to the Tiger, fired a standard armor-piercing round at 773 meters per second. To give that number, meaning the shell was traveling at 2.5 times the speed of sound from the moment it left the muzzle. At 1,000 meters, it could punch through 120 millimeters of vertical rolled steel. The American M4 Sherman, which would form the backbone of Allied armor in Western Europe, had frontal protection of between 50 and 75 millimeters. The mathematics of that equation was not complicated. It was simply brutal. By the time the Allies landed in Tunisia in late 1942, the picture was clear. A single Tiger could destroy multiple Allied tanks at ranges where those tanks could not meaningfully reply. Allied commanders were issuing guidance that amounted to tactical desperation, attack in overwhelming numbers, accept losses, attempt flanking shots against thinner side armor at close range, hope that the Tiger's mechanical unreliability, and it was genuinely unreliable, would remove it from the field before it removed you. These were not strategies. They were methods of controlled catastrophe. The psychological damage was compounding the physical damage. Tiger fear had become a documented operational problem. Allied tank crews who had been briefed on the Tiger's capabilities, and many who had experienced them firsthand, were making conservative tactical decisions that had nothing to do with the actual number of tigers present. A rumor of a tiger on a road junction could halt an advance. A single tank visible at distance could anchor an entire German defensive line simply by existing. British and American intelligence officers were using the phrase tiger phobia in internal reports without embarrassment, because that was exactly what they were observing. British military intelligence and the Special Operations Executive had been studying the Tiger's operational procedures since the first confirmed engagements in Tunisia in early 1943. What they were looking for was not a flaw in the armor. They already knew the armor's limits. Its side plates were thinner, its belly was vulnerable, its engine deck could be targeted from above. What they were looking for was something different. Something systemic. Something that happened not in combat, but in the hours before combat, in the maintenance routines and preparation procedures that determined whether a weapon arrived at an engagement ready to fire. What they found was a bore plug. This is where the story becomes strange, and where a man whose name we do not know enters it. Standard German operational procedure, documented in captured training manuals, and confirmed through the interrogation of multiple prisoners of war, required that the barrel of the KWK-36, along with virtually every other large-caliber tank gun in Wehrmacht and Waffen-SS service, be fitted with a bore obstruction device, when the tank was not actively in combat. This was entirely rational engineering. The 88mm barrel was a precision instrument. Its rifling grooves, machined to tolerances measured in fractions of a millimeter, could be corroded by moisture contaminated by mud or degraded by the general filth of sustained field operations. The plug kept the bore clean. Every army with large-caliber guns used something similar. The standard procedure before engagement was equally documented. The loader removed the plug. The gunner verbally confirmed the bore was clear. The commander ordered the gun loaded. In training in peacetime in controlled environments, this took perhaps 10 seconds and was performed without variation. In combat under fire in the noise and confusion of a sudden engagement, the confirmation step, that brief visual check, that quick sweep of the bore, was sometimes abbreviated. Not always. Not even frequently. The German military was thorough, and its tank crews were professionals. But sometimes. And sometimes was the crack in the wall that British intelligence had been searching for. The device that would exploit this crack was developed in the spring of 1943. It was manufactured in several facilities, including workshops associated with the Birmingham Small Arms Company. It was a length of hardened steel wire between 15 and 25 centimeters long and between 6 and 8 millimeters in diameter, with a small lateral hook or crosspiece at one end designed to catch against the rifling lands inside the bore and resist being dislodged by casual inspection or light probing. The outward-facing end was fitted with a small rubberized sheath that made it visually identical to the standard German bore plug when viewed from outside the barrel. The genius of the device was not the device, it was the delivery system. SOE handlers, working with French, Belgian, and Dutch resistance networks, were tasked not with placing the devices directly, which would have required access to guarded German armored parks, but with inserting them into the German maintenance supply chain. Resistance operatives working in vehicle repair workshops, supply depots, and ordnance facilities where German equipment passed for routine servicing would substitute the false plugs for genuine bore obstruction devices in storage crates and resupply shipments. A Tiger returning from a field workshop after routine maintenance might have its existing plug exchanged for a barrel obstruction device during the servicing process. The crew would receive the tank back exactly as they had submitted it. The plug looked correct, it seated correctly. Nothing was visually wrong. The physics of what followed were from an engineering perspective straightforward. The 88mm propellant charge generates approximately 3,200 atmospheres of chamber pressure at the moment of firing roughly 47,000 pounds of force per square inch. This pressure is designed to be contained by the breech and channeled uniformly down the bore to accelerate the shell. The barrel obstruction device was positioned some distance down the barrel beyond the initial expansion chamber seated against the rifling. When the gun fired, the shell struck the obstruction before it could develop full velocity. The resulting pressure spike was not uniform. It was not contained. The barrel failed at the point of obstruction, fragmenting outward at the moment of peak stress. At those velocities, the fragments of the barrel itself became high-velocity projectiles inside the fighting compartment. In every reliably documented case, the gunner died instantly. German ordnance investigators were initially baffled. Catastrophic bore rupture was consistent with metallurgical failure under combat stress, a problem Krupp had documented in early production runs of certain heavy artillery pieces. The first reports attributed the incidents to manufacturing defects. It was only after investigators began comparing physical evidence across multiple incidents in multiple theaters, and after a partially intact device was recovered from a barrel that had failed to fully detonate the obstruction, that the true cause was identified. By then, between 40 and 80 Tigers and Panthers had been removed from the order of battle, not by Allied guns, not by airstrikes, not by mechanical breakdown, but by a piece of wire placed by mechanics whose names are not in any history book. The unnamed Belgian mechanic working in his occupied workshop did not know the full scope of the program he was part of. He knew only his instructions, his 4 seconds, and the crate of spare parts waiting to be loaded onto the next supply truck heading east toward the front. He did not know how many times the device had already worked. He did not know how many times it would work again. He only knew that he had been given something small to do, and that he was going to do it perfectly. What happened when the Germans figured out what they were facing and how they responded will change everything you think you know about the psychological limits of even the finest soldiers in the world. Because discovering that your own gun might kill you is one thing. Living with that knowledge in the seconds before you fire is something else entirely. The unnamed Belgian mechanic had done his job perfectly. 40 to 80 Tiger and Panther tanks had destroyed themselves from the inside out. The most feared gun in the world had become a death trap for the men who operated it. The barrel obstruction program was working. It was working. And somewhere in a grey government building in London, a senior ordnance official was reading the initial field reports and deciding that none of it was real. His name was Brigadier General Thomas Harwick, and he had spent 31 years in the British Army without once being wrong about anything that mattered. That was not arrogance. That was his sincere and documented belief. He had served in the Great War. He had overseen ordnance procurement in the Western Desert. He had reviewed more technical proposals than he could count, and he had rejected the overwhelming majority of them for reasons that were in his estimation entirely rational. Soldiers wanted weapons. Inventors wanted funding. The intersection of those two desires produced an extraordinary volume of nonsense that someone had to filter, and Harwick had made himself that filter. The barrel obstruction proposal had reached his desk in the summer of 1943, routed through SOE channels with a supporting memo from MY10 that he considered embarrassingly optimistic. He read it once. He read it twice. Then he called the originating officer, a captain named Roland Marsh, from the Technical Intelligence Division into his office and delivered a response that Marsh would describe in his post-war memoirs as the most thorough professional humiliation of his career. "You are proposing," Harwick said, not looking up from the file, "that we win the armor war by tampering with bore plugs." He said bore plugs the way a man says something he has found in a drain. "You are proposing that the Wehrmacht, an army that invented the concept of systematic maintenance doctrine, will fail to notice that their barrel plugs have been replaced. You are proposing that we build our strategic sabotage program around the assumption that German tank crews under combat stress will skip a safety check they have been trained since 1938 to perform automatically." He closed the file. "Tell me, Captain, at what point did you consider that this was not a serious proposal?" Marsh stood his ground. He had prepared for this. "Sir, prisoner interrogations confirm the confirmation step is abbreviated under contact. We have 14 separate accounts from different units, different theaters, different experience levels. The procedure is abbreviated, not always, but consistently enough that 14 accounts. Harwick placed both palms flat on the desk. 14 accounts from men who were captured and are therefore by definition not representative of the competent majority. Dismissed. The proposal went into a pending file. The pending file went into a drawer. 3 weeks passed. In those 3 weeks, Allied armored units in Sicily lost 47 tanks to Tiger and Panther engagements. 47 vehicles. Roughly 200 crew members dead or wounded. The cost per loss ratio, as Marsh calculated it in his own notes, was staggering. Each Tiger destroyed in those engagements had required an average of 6 Allied tank kills to neutralize, and several had withdrawn from battle intact, having killed more than a dozen vehicles in a single engagement. Harwick had not been wrong about everything, but he was wrong about this, and the program was dying in a drawer while men died in burning Shermans. The unexpected ally appeared from a direction nobody had anticipated. His name was Colonel James Whitmore, and he was not an intelligence officer. He was an engineer. Specifically, he was the man responsible for analyzing captured German ordnance samples at the Royal Armament Research Establishment at Fort Halstead, and he had spent the previous 4 months doing something that nobody in the bureaucratic chain of the barrel obstruction program had thought to do. He had tested the device himself, unofficially, in a sandbagged testing bay on a Tuesday afternoon with 2 technicians and a section of salvaged 88mm barrel obtained from a wrecked Tiger recovered in Tunisia. What he had discovered was not what the proposal had claimed. It was considerably worse than the proposal had claimed. The barrel obstruction device did not merely cause a catastrophic bore failure. Under controlled testing conditions, using precise instrumentation, the failure mode was so consistent and so violent that Whitmore had actually stopped the test sequence after the 3rd repetition, because he was concerned about structural integrity of the testing bay itself. The pressure spike at the point of obstruction was not simply exceeding the barrel's design tolerance, it was exceeding it by a factor of approximately 4. The barrel did not crack. It did not split. It disintegrated. Whitmore took this data to Harwick, directly bypassing Marsh entirely because he understood the bureaucratic physics of the situation better than Marsh did. You did not argue with Harwick using personnel. You argued with Harwick using numbers. The device works, Whitmore said, placing his test report on Harwick's desk beside a series of high-speed photographic stills showing the moment of barrel failure. Not theoretically, empirically. We have tested it 11 times against salvaged barrel sections and achieved catastrophic failure in 11 out of 11 trials. The failure is instantaneous, complete, and non-survivable for anyone within the fighting compartment. The device costs 8 pence to manufacture. We have distribution infrastructure through SOE resistance networks that can place it inside the German ordnance supply chain at scale. The question is not whether it works. The question is whether we are going to use it. Harwick looked at the photographs for a long time. Then he looked up. "One formal test," he said. "Full committee. I choose the conditions. If it performs as you claim, I will authorize the program expansion personally. If it does not, this conversation never happened and the proposal is permanently closed. Are those terms acceptable?" Whitmore did not hesitate. Completely. The formal test was scheduled for October 3, 1943, at a military proving ground 60 miles outside London. The morning was cold, the sky the flat gray of an English autumn that cannot decide whether to rain. 12 observers were seated in a raised observation position behind reinforced glass ordnance officers, 2 SOE representatives, a liaison from the American OSS, who had been told only that he was observing a British technical demonstration, and Harwick himself, seated in the center of the front row, with his arms folded and his expression set to a specific configuration that his staff had learned to recognize as professional tolerance. Below them, a complete 88mm gun barrel assembly had been mounted on a reinforced test rig. The bore obstruction device had been inserted by a technician the previous evening. The barrel was then fitted with its standard bore plug, visually identical to any other bore plug in the Wehrmacht supply system. 3 men who did not know whether the obstruction was present had conducted a standard pre-fire inspection using the procedures documented in captured German training manuals. None of them had detected the device. The firing sequence began at 0914. At 0914 and approximately 6 seconds, the propellant charge detonated. The barrel ceased to exist. What replaced it was a cone of fragmented steel traveling outward from the point of obstruction at velocities that the high-speed camera running at 3,000 frames per second struggled to fully capture. The test rig rated to withstand direct hits from standard anti-tank rounds buckled visibly. The reinforced glass of the observation bay developed a crack that nobody mentioned for several seconds because nobody was speaking. Harwick unfolded his arms. He leaned forward slightly. He looked at the wreckage of the barrel assembly for 11 seconds. Whitmore counted before he spoke. How many can we produce per month? The answer at maximum capacity using the facilities already identified was approximately 8,000 units per month. Over the program's most active period production figures suggest that tens of thousands of individual devices moved through the SOE distribution network into occupied Europe, and from there into German ordnance supply chains. The total material cost of the entire program, every device, every unit of manufacturing time, every rubber sheath, every distribution operation, was a negligible fraction of the cost of a single Tiger tank. A Tiger cost the Reich approximately 250,000 Reichsmarks to produce. The barrel obstruction device cost per unit less than the price of a railway ticket. The logistics of the expanded program moved with surprising speed once Harwick's authorization was secured. Production was distributed across 3 facilities to reduce vulnerability to air raids or intelligence penetration. SOE handlers were briefed on the specific insertion protocols, which supply routes, which depot categories, which maintenance cycle intervals were most likely to ensure the device reached an operational vehicle rather than a training unit or a reserve formation. Resistance operatives were given updated guidance that reduced their exposure time during the substitution procedure from an average of 12 seconds to under 4 seconds. The Belgian mechanic and dozens like him had been right all along about the operational tempo. 4 seconds was enough. 4 seconds was more than enough. The first confirmed post-expansion kills began appearing in field intelligence reports from November 1943 onwards. German investigation teams, initially still attributing barrel failures to metallurgical defects, began filing more urgent reports as the incident pattern became impossible to explain through manufacturing variants. 2 Tiger I tanks lost to bore failures within the same week in the same operational sector. A Panther battalion reporting 3 unexplained barrel detonations over a 6-week period. An SS armored regiment requesting urgent guidance on barrel inspection protocols because of what the formal report described as anomalous main gun failures of undetermined cause. The undetermined cause had a name. It had a weight of between 6 and 8 millimeters in diameter, and it was being inserted into crates of ordnance supplies at depots across occupied Belgium, France, and the Netherlands by men and women who would never appear in any history of the war. By December 1943, the German response had begun to take shape. Mandatory bore lamp inspections before every main gun firing. Standardized procedures. New training circulars issued to armored units across all theaters. The 45-second delay that the new procedure added to pre-engagement preparation was not in most tactical situations significant. But the psychological cost was something that no training circular could fully address. Because knowledge of the program had spread through German armored units, not just officially, but through rumor, through the particular kind of fear that travels faster than orders and lodges deeper than doctrine. Tank crews were beginning to hesitate before they fired. That hesitation, that fraction of a second of doubt at the moment of engagement, was about to become the most dangerous thing on the Western Front. Not because it was long, because it was happening to men who had never hesitated before. Men for whom the 88mm gun had been the one absolute certainty in a war defined by uncertainty. And now in the winter of 1943, moving into the spring of 1944, and toward the largest amphibious operation in human history, that certainty had a crack in it. German intelligence had begun to understand the full scope of what they were facing. And somewhere in Berlin, a counterintelligence team was assembling a file on the British barrel obstruction program. They had a description of the device. They had partial information on the distribution methodology. And they had something far more dangerous than either of those things. They had a name, a partial name, a workshop in Liège, a mechanic. And in Part 3, we will discover exactly what the Germans did with that information and why the answer nearly ended the most effective sabotage program of the entire war before it could reach its most critical target. The barrel obstruction program had gone from a drawer in a bureaucrat's office to an industrial operation producing 8,000 devices per month. The unnamed Belgian mechanic and dozens like him had placed those devices inside the German ordnance supply chain with a precision that Harwick's own ordnance division struggled to match in conventional operations. Between 40 and 80 Tigers and Panthers had destroyed themselves. And in Berlin, a counterintelligence file with a partial name and a workshop address in Liège was sitting on a desk waiting for someone to act on it. They acted on it in January 1944. The Abwehr German military intelligence had been assembling their picture of the barrel obstruction program since November 1943, working backward from the physical evidence of barrel failures and forward from intercepted SOE communications that had been partially decoded. What they knew was incomplete but directionally accurate. They knew the devices were entering the supply chain at the depot level, not at the front. They knew resistance networks were involved. They knew the devices were visually identical to standard bore plugs, and that the substitution was happening during routine maintenance cycles. What they did not know, and spent considerable effort trying to determine, was the specific insertion points, which depots, which supply routes, which workshop categories were being used. In January 1944, they began finding out. The method was not subtle. Abwehr officers working with SS security units in occupied Belgium and France began conducting systematic audits of every vehicle workshop and ordnance depot that handled Tiger and Panther maintenance supplies. They were not looking for the devices themselves. They were looking for the people. Any workshop employee with irregular working hours, any depot worker with unexplained access to sealed supply crates, any mechanic who had transferred recently from another facility, all were flagged, interviewed, and in a significant number of cases arrested. Between January and March 1944, German security operations in occupied Belgium resulted in the detention of 11 resistance operatives connected to the barrel obstruction distribution network. 3 of them were directly involved in device insertion. 2 of those 3 did not survive the interrogation process. The third provided information that compromised 2 additional insertion points before his handler was able to shut down those routes and relocate the operatives involved. The SOE's Brussels network lost 23% of its active logistics personnel in a 6-week period. The program did not stop, but it slowed. Device insertion rates fell by roughly half during February and March as handlers rerouted supply chains and established new cover identities for replacement operatives. The Germans had not broken the program, but they had heard it, and they had introduced something more damaging than the operational disruption itself. They had introduced fear into the network at the human level, the kind of fear that travels faster than orders and damages operational security in ways that are almost impossible to quantify. The program was under pressure from another direction simultaneously. Back in London, a technical review committee convened in February 1944 had identified a problem that the initial field testing had not fully anticipated. The rubberized sheath on the outward-facing end of the barrel obstruction device, designed to make it visually indistinguishable from a standard bore plug, was degrading in cold conditions. Specifically in temperatures below -8 degrees Celsius, the rubber compound was contracting sufficiently to alter the device's external dimensions by between 0.5 millimeter and 1 millimeter. Still within visual tolerance for a casual inspection, but not within tolerance for the new mandatory bore lamp inspection procedure that German armored units had implemented since November 1943. 3 devices had been recovered intact from Tiger barrels during routine maintenance inspections conducted by German crews following the new procedure. 3 recoveries meant 3 near misses. 3 moments where the program had come within a bore lamp's range of being detected and catalogued in a way that might have allowed German engineers to develop a systematic counter that went beyond the inspection procedure already in use. The Technical Review Committee was in the language of its formal report concerned. Whitmore, who was present at the committee meeting, used different language when he spoke to Marsh afterward in a corridor outside the meeting room. "They're going to recommend suspension pending redesign," Whitmore said. Harwick is leaning toward it. 3 recoveries in 3 months and a compromised distribution network. From his perspective, the calculus has shifted. Marsh looked at him. "D-Day planning is finalized. The landing is spring. If we suspend now and the redesign takes 2 months, we miss the entire Normandy campaign." Whitmore nodded. "I know." The suspension recommendation was overruled not by Whitmore or Marsh, but by a signal from SHAEF Supreme Headquarters Allied Expeditionary Force that arrived on February 28, 1944, and made the committee's deliberations effectively irrelevant. The signal referenced intelligence indicating that German armored reserves in France included at minimum 4 Tiger-equipped heavy tank battalions that would be deployed against any Allied landing in northern France. It requested in language that left no room for interpretation that the barrel obstruction program be maintained at maximum operational tempo through and including the anticipated invasion period. The rubber compound issue was to be addressed through revised storage protocols, not program suspension. Insertion operations in compromised areas were to be temporarily suspended and redirected to alternative routes. The committee reconvened. The suspension recommendation was withdrawn. The program accelerated. On June 6, 1944, Allied forces landed on 5 beaches in Normandy. By June 8, the first German armored counterattacks were developing, spearheaded by elements of the 12th SS Panzer Division and the Panzer Lehr Division moving north from their assembly areas toward the beachhead. Among the armored assets being committed were Tigers from the 101st SS Heavy Panzer Battalion, the unit that included Michael Wittmann, at that point the highest-scoring tank ace in German service, a man with over 100 Allied vehicle kills to his name, and an 88mm gun that had never once failed him. The 101st SS Heavy Panzer Battalion reached the operational area around Villers-Bocage on June 13, 1944. What happened that morning in the town and on the road leading into it has been documented extensively from the German side, primarily through Wittmann's own account and the accounts of surviving crew members. Wittmann's Tiger destroyed approximately 14 Allied vehicles in a single engagement along the main road, an action that has been described as one of the most remarkable individual tank actions of the war. This part of the story is well known. What is less well known is what happened to 3 other Tigers from the same battalion that day and in the days immediately following. 3 Tigers from the 101st SS attached to the Villers-Bocage operation reported main gun barrel failures during the June 13th to June 15th period. German after-action reports, several of which are held in the British National Archives, attribute 2 of the failures to combat damage. The third report, filed by the battalion's technical officer on June 16th, describes a bore failure consistent with obstruction and requests urgent guidance from Corps Ordnance on inspection protocols. The technical officer's report notes with a precision that suggests he understood exactly what he was describing, that the failure occurred at the moment of firing against an identified target at approximately 800 meters range. The gun had been loaded. The crew had performed the standard inspection. The commander had ordered fire. The barrel detonated. The gunner died instantly. The loader was critically wounded. The Tiger was lost not to Allied guns, but to itself. Villers Bocage was a tactical German success on June 13th. Whitman's action temporarily halted the advance of the 7th Armored Division and forced a British withdrawal from the town. It was cited in German propaganda as evidence of Tiger superiority. What the propaganda did not include was the battalion's actual combat strength over the following week, which was reduced by mechanical failures, Allied artillery, and bore failures to roughly 40% of its nominal establishment by June 20th. A unit that arrived in the operational area with what should have been overwhelming local armored superiority was combat ineffective within 8 days. The bore failure rate within German armored units operating in Normandy during June and July 1944 cannot be precisely separated from total main gun losses, because the German reporting system categorized many failures as combat damage in initial field reports that were never subsequently reviewed. But the pattern across multiple units is consistent. The 2nd SS Panzer Division, Das Reich, moving north from the Périgord toward Normandy after the massacre at Oradour-sur-Glane, reported 3 unexplained barrel failures during the march. The Panzer Lehr Division, which bore the brunt of several major Allied counterattacks during July, reported barrel failures at a rate that its own technical officers found statistically anomalous. Anomalous was the word they used. They meant inexplicable. They meant that the finest gun in the world was killing its own crews, and they could not consistently determine why. By July 1944, German armored doctrine in Normandy had adapted in a way that was tactically visible to Allied commanders, even though its cause was not fully understood until after the war. Tiger and Panther commanders were taking additional seconds before firing. The bore lamp inspection, which added 45 seconds to the pre-engagement procedure in controlled conditions, was taking longer under combat stress because crews were conducting it with a thoroughness that training had not previously required. Allied after-action reports from armored units in Normandy note across multiple engagements that German heavy tanks were engaging more slowly than their technical capabilities should have permitted. One British tank commander's report from late July 1944 describes a Tiger that had acquired his vehicle at approximately 600 meters, clearly had a firing solution, and then appeared to hesitate for what the commander estimated as 5 to 10 seconds before firing. The Tiger missed. The British tank did not. 5 to 10 seconds. The length of a bore lamp inspection conducted by a man who was no longer completely certain that the gun he was about to fire had not been turned into a weapon against him. The barrel obstruction program did not win the Battle of Normandy. No single program wins a battle of that scale and complexity. But across the 2-month campaign, Allied intelligence assessments suggest that bore failure-related losses accounted for between 8% and 12% of total German heavy tank losses in the theater at a program cost that was a negligible fraction of a single tank's production value. More significant than the material losses was the systemic degradation of German heavy armor's primary tactical advantage, the ability to fire first, accurately at range, with absolute confidence in the weapon. That confidence was gone. Not entirely, not irreversibly, but measurably. German tank crew veterans interviewed in the 1970s and 1980s consistently describe a period beginning in late 1943 and running through the Normandy campaign, where the pre-firing moment, that instant between acquiring a target and pressing the trigger, carried a weight it had never carried before. A weight that had no name in German training manuals, because it had not existed until a Belgian mechanic working in a Liège workshop began swapping one small metal plug for another in 4-second intervals. The barrel obstruction program was formally closed in August 1944, as Allied forces broke out of Normandy and German armored strength in France collapsed under the combined weight of air power artillery and the operational failures that the program had contributed to accelerating. Whitmore filed a final technical assessment. Harwick signed the closure authorization without comment. Marsh, who had spent 14 months fighting for the program's survival against bureaucratic resistance, German counterintelligence rubber compound failures, and committee reviews, received a mention in dispatches that described his contribution in language so deliberately vague that it communicated nothing to anyone who did not already know what had happened. The unnamed Belgian mechanic from Liège was never publicly identified. The SOE archives contain a reference partially redacted to an asset in the vehicle workshop network who was extracted from Belgium in April 1944, following the deterioration of the distribution network security. His subsequent history is not recorded in any declassified document. He may have survived the war. He probably did. He certainly deserved to. But the story of the barrel obstruction program does not end with the program's closure, or with the liberation of Belgium, or even with the end of the war itself. Because what the program proved, what it demonstrated in terms that military engineers and intelligence services have never entirely stopped discussing, raises a question that has no comfortable answer. If the most sophisticated killing machine of the Second World War could be defeated by a piece of wire costing 8 pence, inserted by an anonymous mechanic in 4 seconds, what does that tell us about every weapon system that has come after it? What does that tell us about the relationship between technical sophistication and vulnerability? Between the tolerance that makes a weapon deadly and the tolerance that makes it fragile? That question and the full accounting of what the barrel obstruction program cost and what it saved belongs to Part 4. Along with the story of the one man whose name we do not know, and whether history has any obligation to remember people it cannot name. From a wire costing 8 pence inserted in 4 seconds by a mechanic whose name history never recorded, to between 40 and 80 of the most feared tanks in the world, destroyed from the inside out. The barrel obstruction program had gone from a rejected proposal in a bureaucrat's drawer to an industrial operation that put a crack in the psychological foundation of German armored warfare. The Boer failures in Normandy had slowed Tiger commanders at the precise moment when speed was the difference between killing and being killed. The program had been closed in August 1944, with a mention in dispatches so vague it communicated nothing to anyone who did not already know the full story. But what happened to the people inside that story? What happened to the unnamed mechanic, to Marsh, to Whitmore, to the resistance operatives who had spent 2 years swapping plugs in occupied workshops, while German security units searched for them by name? The program ended. The files were classified. The war ended. And then the silence began. Because the story of the barrel obstruction program has one final chapter that almost nobody knows, and it concerns not what the program achieved, but what it cost and what it proved, and why those two things are not the same question. The SOE extraction record from April 1944 contains a reference in partially redacted form to a mail asset extracted from the Brussels network following the security compromise of the Liège distribution routes. The asset is described as having been operational for approximately 11 months, as having completed an estimated 340 individual insertion procedures over that period, and as having been relocated to a safe house in southern England pending resettlement. His subsequent history is not traceable through any declassified document in the British, Belgian, or French National Archives. He was given a new identity as part of the standard SOE resettlement protocol for compromised assets. He was, in the language of the intelligence services, sanitized, meaning that his connection to his operational role was formally severed to protect both him and the network's remaining personnel. What this means in human terms is simpler and harder than the bureaucratic language suggests. He survived. He was given a new name and presumably a new life somewhere in Britain, or possibly in Canada, where SOE maintained resettlement infrastructure for European assets. He would have been in his early to mid-30s at war's end. He had spent 11 months performing an act of extraordinary precision and courage in 4-second intervals in a workshop that smelled of axle grease and occupied Belgium. He had contributed to the destruction of dozens of the most powerful tanks in the world, and nobody, not a newspaper, not a government, not a history book written in the subsequent 80 years, has been able to confirm his name, his post-war occupation, or whether he ever knew the full scale of what his 4 seconds had accomplished. Captain Roland Marsh, who had fought for the program's survival through Harwick's rejection of the rubber compound crisis. The network compromise and 2 committee reviews was demobilized in 1946 and returned to civilian engineering practice. His post-war memoir, published privately in 1962 in a limited edition of 200 copies, contains a chapter on the barrel obstruction program that was submitted to the War Office for security review and returned with 11 passages redacted. The published version describes the program in general terms that confirm its existence without specifying production figures, distribution routes, or individual agents. Marsh sent a copy to Whitmore. He sent a copy to Harwick, who by then was retired and living in Wiltshire. Harwick's response, preserved among Marsh's papers and quoted in a 2019 academic article on SOE technical programs, consisted of a single sentence: "You were right and I was wrong, and I should have said so at the time." That sentence took 19 years to arrive. Marsh described receiving it as the most professionally satisfying moment of his post-war life. He died in 1978. His memoir is held in the Imperial War Museum and is not currently digitized. Colonel James Whitmore remained at the Royal Armament Research Establishment until 1955, during which time the principles demonstrated by the barrel obstruction program that high-pressure weapon systems create corresponding vulnerabilities at their operational tolerance limits were formally incorporated into British Ordnance Vulnerability Assessment methodology. The bore obstruction concept was studied, tested, and refined during the early Cold War period, as both NATO and Warsaw Pact planners evaluated potential sabotage methodologies against each other's armored forces. The specific device was not used operationally in Korea or Vietnam in any form confirmed by declassified records. But the principle it demonstrated, that maintenance supply chain interdiction could be as strategically significant as direct weapons engagement, became a documented category in military planning doctrine that remains active today. Whitmore received a CBE in 1952. The citation does not mention the barrel obstruction program. It references his contributions to ordnance research in general terms that would have been meaningless to anyone outside a small circle of people who knew exactly what those general terms were describing. The program's technical legacy extended in directions that its originators did not anticipate. The analysis of bore failure modes conducted during the program's development contributed to post-war improvements in barrel inspection methodology that became standard practice in NATO armored forces. The mandatory bore lamp inspection that German forces implemented in response to the program. The procedure that added 45 seconds to pre-engagement preparation and introduced measurable hesitation into Tiger crew behavior, was studied by British Army analysts and incorporated into tank crew training as an example of how procedure design affects combat performance. The lesson was not about barrel obstructions. It was about the relationship between confidence and procedure, and about what happens to a weapon system's effectiveness when that confidence is compromised. You do not need to destroy a weapon to reduce its effectiveness. You need to make the people operating it uncertain about whether it will work. That insight, documented in a 1951 internal Army analysis titled Psychological Factors in Weapon System Reliability, has been cited in military psychology literature continuously since its declassification in 1989. The broader lesson the program demonstrated is one that military historians and innovation theorists have returned to repeatedly, not because it is complicated, but because it is uncomfortable. The barrel obstruction program succeeded because someone looked at the most powerful tank gun in the world and asked not how to defeat it directly, but how it failed. Not how to build a better gun, but how the existing gun's extraordinary performance created an extraordinary vulnerability. The Tiger's 88mm weapon was lethal precisely because it operated at pressures that left no margin for error. Remove that margin, and the weapon destroyed itself more completely than any Allied gun could have managed from the outside. This is not a comfortable lesson for institutions designed around the accumulation of superior capability. Every army, every technology company, every organization that pursues maximum performance eventually builds systems that are maximally fragile, not despite their sophistication, but because of it. The barrel obstruction program demonstrated this principle at a cost of 8 pence per unit against a target that had cost 250,000 Reichsmarks to produce. The ratio is in every sense instructive. 3 similar examples from the same war reinforce the point. The German Enigma cipher system was compromised not by a superior cipher, but by the procedural habits of the operators who used it. The same operator's phrase, the same message structure, the routine human behaviors that introduced predictability into a mathematically secure system. The Japanese naval communication protocols that allowed American signals intelligence to anticipate the Midway operation were not cryptographically weak. They were operationally consistent, and consistency in a high-security system is a vulnerability. The British bomber stream that defeated German radar-guided night fighters during the strategic bombing campaign was countered not by better radar, but by window strips of aluminum foil dropped from aircraft that cost fractions of a penny each and blinded a billion Reichsmark defense network. In every case, the same principle. Sophistication creates fragility. The tolerance that makes a system powerful is the tolerance that makes it vulnerable. The detail that most people who know the barrel obstruction program's history do not know concerns the first test device. The prototype. The original barrel obstruction device tested by Whitmore in his sandbagged Fort Halstead testing bay on a Tuesday afternoon in the spring of 1943. The test that produced results so violent, he stopped the sequence after 3 repetitions was retained after the test series as a reference sample. Standard procedure. It was cataloged, stored, and transferred through the normal archival process when the program closed. It spent several decades in a Ministry of Defense storage facility in Wiltshire. In 2003, during a routine archival review that was consolidating Second World War SOE technical program materials, a researcher identified the original catalog entry and requested the physical item for documentation purposes. The storage facility responded that the item had been transferred. The transfer record indicated it had been sent in 1971 to a workshop in Birmingham for assessment as part of a review of wartime manufacturing techniques. The Birmingham facility had closed in 1974. Its materials had been dispersed. The original prototype, the first barrel obstruction device, ever tested the 8-pence piece of wire that started an argument that Marsh won, and Harwick eventually acknowledged, and Whitmore proved with a high-speed camera running at 3,000 frames per second, is currently unaccounted for. It is with reasonable probability sitting in a box somewhere, in a storage unit or a workshop clearance lot, or a private collection acquired without knowledge of its provenance. It looks like a short length of hardened steel wire with a rubber tip. It looks like nothing. It is arguably one of the most consequential small objects of the Second World War, and nobody knows where it is. From a Belgian mechanic performing 4-second insertions in an occupied workshop to an 8-pence wire that fractured the confidence of the most feared armored force in the world. The barrel obstruction program proved something that military history keeps proving and institutions keep forgetting, that the gap between a weapon's maximum performance and its catastrophic failure is often measured not in armor thickness or caliber or muzzle velocity, but in the 4 seconds a tired man decides to skip a safety check. The program saved Allied lives in numbers that cannot be precisely counted, destroyed German armored assets at a cost ratio that no conventional weapon could match, and demonstrated a principle of systemic vulnerability that defense planners on every continent have studied quietly and seriously for the 80 years since. If you know of another story from the Second World War where an idea this simple changed something this large, put it in the comments, because the history of this war is full of unnamed mechanics in occupied workshops, and most of them are still waiting to be found. Subscribe if you want to keep looking. The greatest weapons of the 20th century were not always defeated by better weapons. They were defeated by better understanding. And understanding, unlike armor, costs almost nothing to build. The unnamed mechanic from Liège understood that. He understood it in 4 seconds, in a workshop in the dark in occupied Belgium, with his hands on a crate of spare parts, and his entire life balanced on the question of whether the man who would eventually fire that gun would take 45 seconds to check that it was clear. He bet everything on the answer being no. He was right enough times to matter. That is all history required of him. That is all it requires of anyone.